So, before starting the today's session, students, please be quiet. Right? Okay. Do you have any problem about programming tutorials? Not practical. No. Let me know if there are any general questions that I will tutorial session. Right. So today we are going to talk about data structures. So before that, do you have any problem? Clarify about the structures. So actually, today, so students from this home, if you have any particular questions from the lab sheet that we'll need to discuss, please put them into the chat. Then I can arrange another tutorial session that for discuss about only those questions. Right. So before going to the more details about the data structure. So what are the data structures you already know? බාලා දැනට දන්න data structures මොනවා? Yeah. So Kalhar said arrays, right? Arrays and data structure. So what are the data structures you know? The data structure. All of data structure that we are using, right? Pointers, what we are holding is a particular memory address, right? Right. So struct variables, arrays, those are currently you aware. So today we are going to learn more about those data structures. So one particular thing is this stack. So it is mentioned it's an abstract data type. Right. So what is that? Is that this abstract data type? So when it comes to the variable you can store integers or any kind of integers, float, decimal. There are several. the structure also data structure. So actually we are going to create this stack and other data structure that you are going to create from this structure, right? So in there, they are actually really aware, right? Those are in so by mean this abstract means they are defined as some conceptual conceptual or logical way, not kind of physical. That you are learning on this variable set, arrays, and structures. So that's what means this abstract data type. So so by being abstract, that means they have some necessary rules that you need to follow. So that necessary rule is first in, last out. So what that means is if something put into that particular data structure, right, then we can keep adding those things to those particular data structure. But the first, the initial insertion or initial certain element will be going to out from that particular data structure the very right. So we'll explain more about that part. So something like this I really don't remember the English term when you are doing maybe in chemistry, like there's something you remember there was some step like this. To measure particular liquid, right? Therefore, there is something like and right. So let's consider this is some kind of that element. So you can put something inside to this particular element one by one, right? So what is the thing here? So you put something to inside, so that last inserted element will be in the top, right? මොකක් හරි අපි මේකට දැම්මොත් ඒ අන්තිමට දාපු එක තමයි උඩටම එන්නේ, right? So in stack also that happen, right? So that means we are push those things to the stack. So as mentioned here, we can push push something into this stack, and when we need to take something out, so the top of the element will only be can exclude from this particular object, right? So like that, we can say it is, we can only pop out the very the object that is in the very top of the this particular object, right? So insertion, that means push any item into this stack, and when we need to delete something, we are going to pop out the most recently inserted item, right? So it is very simple term. So that means there is some object like this. There is some object like this, and we can add anything like let's say if it is created by to add integers, so that we can add in an integer. Likewise, we can add anything, but when we are deleting the topmost element, this one will be deleted. If we need to delete the bottom element, how we can delete that? So it's like some object, right? And on we can insert anything, like let's say we created this stack using to insert integers, right? And yeah, keep adding integers, and only the topmost element, that is recently added inserted element, will be only be deleted, right? My question is how we can delete this last element. කොහොමද ඒ අන්තිම එලිමන්ට් එක අපිට delete කරන්න පුළුවන්? හරිද? ඒ මොකද ප්‍රශ්නේ තේරුම් ගන්න? So I'm asking a very simple thing. How you can delete this last element? There are only one rule, that is the topmost element only we can access and only we can delete. Then how we can delete the last element? So he said we delete the whole top of these things. Let's say 40, we can delete 40, right? Then we can delete 30, then 12, 11. Likewise, at the end we can delete the last element, right? You need to just like just if you understand that thing, then that is the whole part of the stack. Stack yani itara. But me anti element itara no na. Jadi ko kuma itara. Right? But now I am editing that same section. I am saying only delete this last element. What I am saying is you need how you can only delete this last element without deleting these ones. Like you can do anything, but at the end there should be something like this. I'm creating a particular stack, right? So bottom element is 10, 11, 12, 13, and 14. So I am asking to create this one. So the bottom element should be 11, 12, 13, 14. Right? How you can do this? So Kalhara said we can reverse the stack. So I'm asking how you can how you are going to reverse this stack, right? If this stack can reverse to something like this, then we can easily delete this element, right? Then what we need to do is reverse this back to the this question, right? But I'm asking how you can do that. So if you need to reverse, you need to mention how you are going to reverse that. Right. Well, I important, right? So what he's saying is, so what he said is he is removing all the elements up to 10, then remove that one and reinsert the whole thing again. So what we can do is we can without removing, we can input the same thing to another stack, right? So we can access the 14. 14 will be here, 13 will be here, then 12, then 11, right? So these things will be removing this particular stack, then we can delete this one, right? Like we are throwing some garbage. Very simple, right? Then after that, we can add these. Consider this is the same stack. So now it is empty, right? Now this stack is empty. Now we need to put this okay, right? So 11, we are putting here 12, 13, and 14, right? There is nothing to learn, right? So I think so it is the whole thing that you need to learn about stack. So when you are like need to develop that particular stack in C, what you can do is you need to create a node. So I will teach you how to create the code as well. After next data structure is given. After that, I will taught you how to create the linked list. So you need to develop this kind of a stack. The linked list will be some easiest way to develop this kind of a data structure when you're using C, right? So without using linked list also, you can create this particular stack. In there, you can use the array data structure. So by arrays also you can create the same thing, but like most efficient way is using a linked list. So in your linked list, what you need to do is create the node. So I will do these things after the linked list. Then same stack initialization. You need to create these two operations, push and pop. Right? Push means you need to delete, insert something very like the stack is something empty, then you need to put into the bottom, right? So if the stack is not empty, then you can need to the very topmost element from the bottom. So you need to insert there, right? So if you need to delete a particular element, what you can do is you need to access the topmost element and only delete that element. So all other operations like deleting something from the middle or deleting the last element or deleting only some very particular element and then others should be as it is, right? So those can be coded as I mentioned when inserting also. As I mentioned, you need to think about how to do this. So you need to create your own algorithm, right? So it's about stack. So then queue. So before going into the queue, do you have any? Do I need to explain this again? Right, let's discuss when we are to the coding. So next data structure is queue. So before that, right? So here in stack it is first in, last out. That means the first initialized element will be going to out at the last move, right? But what happened in queue is the most impact. I mean the first initialized or first inserted element will be going to uh, going to pop out in the very first, right? So that is only the difference. So it is also abstract data type. So as I mentioned, first element added to the queue will be first one to remove, right? So it is something like this. It's the actual queue. So let's consider this is show queue and if something inserted, so they will be in the very top, right? Initial, right? Let's consider this. And if you need to Let's consider particular object like a maybe a water pipe or something. So you can add from this end and deletion happen in this end, right? So you add some particular elements like this. So you can only add from here, right? So initially added element will be in this set, right? So likewise, you can add elements. So here you can only add elements, and from here it will going to pop up or delete, right? So this is that particular structure. So consider something like this. So if something added to here, it will go very edge, right? So consider you need to add this element 9. So where I should add. So this is the cube. So you can add, consider you can add anything, any number of elements, right? So now I ask you to add this number 9 to this cube, right? So as I mentioned here, only adding can be done in this page and deletion will be happening this page. So where should I put this 9? Can you able to draw that? This row after you add 9, how it will be? Please draw that you. So you got the correct answer, right? So correct answer is something like this. Here number 9. 40, 70, 12, 11, 10. Right? So this is the correct answer. It will inside it here. Right? Now I'm asking you to draw all the steps that will lead to do create this particular queue from this one to this one. So you need to do all this step. Please do all this step from this queue to this queue. That how you are going to create this particular queue from using this queue. So in every step, you can add one element and you can remove only one element. So you need to keep an idea. You can add the element from here and you can only delete an element from this side. Right? So do all this step that is necessary to create this element from the initialize this queue. Yep. So students from the Zoom, if you're able to do this one, please put them into the chat. Right. So I will discuss this question. So since this is a queue, so we can access this particular element, right? And when we need to add something, we need to add something to this set, right? So what we can do is these are our elements. So we can remove this one, this 10, and we can insert it here, right? So likewise, we need to keep doing the same thing over and over again. Right. So this is the some special thing that you can do when you are using cube. So consider the same thing. This is a cube. So it is a stack, right? So and here 9. So from this to this, what you can do. So please do this step as well. So how you can create this stack by using this stack. So we have done the same thing using cubes. Now I'm asking to do the same thing by using the stack. So what you need to do is please draw each steps that is required to generate this cube, this stack using this particular step. So one of your friend asks that can we do any changes to this particular object, like any mathematical operation like reducing or something? So actually you can do if this the corresponding element is top of the stack. That means this one. For this particular element, number 9, you can do anything, right? Multiplication, division, anything you can do because it is in the top of the stack. So actually, when you need to do anything, what you can do is you need to first remove this particular element from the stack, and then you can do the necessary changes, necessary operations. Then you can insert back into this particular stack. Here in queues also, if you need to do any particular changes. So, what is the actual element that you can do? So, there are 6 elements in this particular queue, right? So I'm asking, what is the element you can take in order to do some, let's say, addition? You need to add one, right? You need to add one to a particular element. So here, what is the element that you can use? Is however you can insert to this end and delete from this end, right? So it should be either 14 or 30, 14 or 9, right? So what is the element that you can access to this in this particular queue? Number 9, right? Because how you can do any operations, the way is first you need to remove that particular element. So to remove something from a queue, so the first initial inserted element only can remove in a stack in a queue, right? So that means this number 9 will only remove, right? And let's say you inserted one there, then that means will be, so you are removing this one plus 1, 9 means 10. So now you need to put this 10 to this queue. So what will happen? So it will go in the very beginning to here, right? Like this. But in this particular data structure, that means the stack, if you need to add one, so this will be removed, right? Then you need to put this to the back. So it will go to the very first or the very the topmost as the topmost element. So in there, the both adding and deleting will happen. Here, adding will happen here, deleting will happen here, right? So insert this particular element. You need to assign this to a maybe for my question was from this to this, right? So this thing should be you can create an empty list or empty stack, right? and you can add this number 9, right? Then you need to add number 12. So you can create another stack in there. You can add this 12, 11, 10. And from this, you can add elements to the here. So in that way, this one will be an empty stack, right? So otherwise, what you can do is you can assign this number 9 to a particular variable, and you can pop out each element as to this, as I mentioned in this step. Then you can add this 9 to our main stack, and then keep adding elements from this stack. So in this way, only 2 stack will be going to use, right? So there are several steps you can do create this stack, right? So what you really need to know is this stack can use a very simple data structures, and there are several rules that are in stacks. You can add only the most recently added element will be removed in a stack, and what will happen in queue is the initially added element will going to remove in a queue, right? So those are the two things. So like for creating the node queue initialization. So there are two operations. Put, that means the insertion, and get means deletion, right? So the next one. So here I will teach you how to create those stack and queues by using this linked list data structure. So linked list also is a particular thing. Yeah. Right. So this, there are several linked list structures. So here I'm going to teach about this one-dimensional linked lists, and there are more two-dimensional circular linked lists, bidirectional linked lists. There are many number of linked lists. As mentioned, cyclic code update link link. Right. So it is something like this. There is a node, and it has a point. Consider this is some kind of a data unit. There is a pointer, and this is the data, right? If this is the initialized linked list, that means the very first node of a linked list. So let's say our name of our linked list is A. So A will refer this uh, A will refer the very first address for this particular link or this particular node, right? So that means A has the memory location of the initial node, right? So it has the memory location of the initial node, right? So consider this linked list is named A, and A has the memory location for this initial node, and this particular node contains two things. So one thing is data, that is in array we are holding our data, right? 10, if it is an integer array, then 10 level, likewise those integers. Here in this particular cell, it holds the data, and in this particular cell, it is a pointer that is going to point to the next node. So this node, so this is the next immediate node. So it has also the some storage for holding particular data, and it also has the same characteristic. That means here also another pointer that will point to next immediate node, right? So likewise, there can be infinite number of nodes that in a linked list. So we need to define that number. So yeah, we can't say it is infinite. There are a finite number of nodes, and consider this is the final. So this is the data. So this final node pointer variable will be, right? So what that means, since there is the memory location, so if we ask for the next pointer, so but it means, so it means this particular node from starting A, the next means this particular node, and the next we can go again. So there are no any particular index, right? No any indexes. We can call this pointer. So the pointer name will be next, right? Right. By calling this, we can access these node sequenced from the very first node, that is A. The next will be this one. Next will be this one. So likewise to the very end. Right. So as I mentioned in this structures, we are using structures. So consider you need to create an integer node. So it has two things. So one thing is this pointer, right? This pointer, and the next thing is this data, and it will only hold integers, right? So I'm asking create this initialize for this very first node, you need to write the code for this particular node by using structures. So in structure, the first one is this pointer. So the pointer name is next, right? And the data. So data will be an integer value. So please create this particular node by using this structures in C. So you need to write down the code. So I will explain again, right? So consider a particular node and it has two things. The දැන් අපි structures ඉගෙන ගන්නවා structure එකක් කියනවා. Structure. In a structure, we can hold any number of, let's say, integers, anything we can hold in a variable, right? In structure variable. See. So consider this structure. So it is a structure name is person. And there are name, city number, the citizenship number, and the salary. So there are three things. So this is a, we can call this is a person node, one person node, right? So in that node, there are three things. One is the character array, it has 50 array size, and the next one is an integer, is the like NIC number, and the third one is the salary. It is a floating point value, right? So consider the person. It has three things, right? What are those? Name and the NIC and the salary. So name is some kind of a character, right? So NIC is an integer, right? And salary is something floating point value. Likewise. So this is a particular node, right? So there are several nodes, that means several persons, right? So in our problem, in the linked list, linked list is something like this. So there are two things. What is the first one is this data. Here it has data. So I'm asking you to create an integer. That means this particular data, it will go into hold and integer value, and it has a another value. It is a pointer. That means memory location. That is going to call the next memory location of the next node, right? So I'm asking you to create that particular node, right? Using structures. So the name A, something like. So there are several things. So one is that pointer next, and the data it should have data is an integer value. That means it can hold any integer value, right? Right. That code. Students from the Zoom, please let me know if there are anything I need to clarify. So this is the way you need to define this structure. So however, it is a structure, right? This is a structure. So keyword is structure, right? Then what you need to have a name, right? So let's say it is not, right? So first consider we need to have a data, right? So data is in integer type, as I mentioned. Data, right? So in this means in this particular node, we ask for this particular data, we can store any integer value, right? So next thing is that pointer to what? Huh? Pointer to what? Next node, right? Next, this particular node. It has the same characteristics, right? So what is the data type? Huh? Data type එක මොකක්ද? ඒ කියන්නේ ඊළඟ the next is the same, this kind of a node, right? So let's consider this next. The name is next, right? So as I mentioned, it is what? Yeah, it is a structure, right? And it is a memory location to that next node. So node is a structure, right? So what's the data type? Structure node, right? Struct node. Right? Struct node. You need to put this stuff, otherwise it can't identify this is a pointer. Very simple. We have a data to store any data in this particular node, right? And next we need to have a pointer to next node, right? Next node. Right? So this is the basic structure of a node. So here we are declaring the structure for node and our data and pointer for next node or the another node, right? Right. So that is the definition. This is the basic structure of the definition. And if you remember last week, so I asked after the definition, we need to initialize, right? So how we are going to initialize? By using this malloc, right? Because we don't know about the size of this structure. Yeah, we can know it has this integer. Integer means 4 bytes, and the pointer. So I remember 8 bytes or something. Need to verify that one. So by using this malloc and this size of, right, we can initialize some particular node. So here I'm initializing a temporary node. So this temp is what? Temp is what? This is called, right? As I mentioned, this malloc. So before to understand this temp, what you need to understand this particular part, right? Struct node is some is what is inside this bracket, and there is a function called malloc. So size of function will return the size of this node, right? So it is has a size, and in memory allocation malloc, we can allocate some memory, and then what will happen in malloc? After allocating a particular memory, what will happen? It will return what? Memory address to a right. So consider this is your memory, right? This is your memory. Some conceptual idea, right? So there is a node, right? We are initializing a node inside our memory, right? So this is as so integer. So this name is data, and this one is next, right? So we have initialized or allocated a memory using malloc, right? So name is temp, right? So what is the? This also a memory address, right? This also has a memory address. The name. Here, temp also address to a particular node, right? So what will happen in malloc? As we are allocating memory using malloc, and there should be a way to access this memory, this particular node, right? So how we are going to access? By using the memory allocation to this node, right? So there should be a memory location. So malloc will return that initial memory address, right? And the what is the type? It can have any type, right? So we need to type casting to our struct node, right? So here also, what is the type? Struct node. So we need to type casting. Then we know this particular memory portion will have a node in the type of struct node, right? So it has that memory address, and we are allocating, right? So this temp will be that memory address. Here, with this assignment operator, we are assigning that return memory location to this particular node to this temporary temporary variable, so it is a pointer. And what is it has the memory address to this particular node, right? So in this here, the memory allocation will happen. Right. So let's discuss about this stuff. So how you know creating a node, and we need to initialize the whole list, right? Whole linked list, and we need to know how we are going to insert the particular node and delete also. And searching for some kind of a value, that means some kind of a data in the our linked list, and print also. Right. So this is the linked list. As I mentioned here, we can declare the structure, right? Can declare the structure. Then we need to declare the start where so first we need to have that template to create the nodes. So here is the template, right? Template means some kind of a block or something. So single, you can say achua, right? අපේ list එකේ note හදන achua තමයි මේ තියෙන්නේ, right? Then by using this template, we can create any number of nodes, right? Any number of nodes can be created by using the template, right? So template is this structure. Right. So after that, we need to have where we are going to start. So let's say this is the start. We'll start with point out this particular node, right? So initially, we can say it is not. That means there are no any data or no any value, right? Initially it is not. And our function insert to the front, right? So start, so it has this particular node. So we need to have something that some function where we can insert something to the front, right? So you can do anything like insert to front, rear, or in the middle. You can create those functions your own. Here I'm talking about insertion to the front and to the rear, create and display over the linked list, and deleting from front and deleting from rear. And this count will represent how many number of elements are there in this linked list. So it has the size of the linked list, right? So these are our function prototypes, right? So this is the count is what? Global variable, right? So this is the insertion to the front. So we are creating another temporary variable for a node, and here we are initializing, right? So since we are creating a particular node, so we can increase this count value, right? Say the start is now. Here our initial start variable or start pointer is null. That means there are no any elements. So that means linked list is empty, right? If it is empty, then we can simply say the start the T also has this particular memory address. So we can assign it that to the start, right? And the data. So it will be the data that we are going to insert, right? And the next, why next is null. So next means this one, right? Start next is this pointer. Why it is null? There are no any elements, right? Because it is the very first. So it is the first case, right? Right. Then we can return the function, right? So otherwise, if list is not empty, so the is data is x and uh, is next is start, right? Why that? But what will happen here? So consider the linked list is not empty. The linked list is not empty. So we have created the temporary node. So it is called T, right? This next is null. And there is a data our x, right? So since we are starting, we are inserting this key to the front. So what we can do is, uh, we, we can say this pointer is pointing to this star, right? So that means this node, right? This pointer will point to this node. Then this we can remove this star to point to this one, right? And the data will be this x. Start data will be this x. That will happen here. T data is x, T next is our start, then start is become our T. Right? So what will happen? It's going to start here, so data is x, and this one is pointed to this. So we can insert to very front. So if the list is empty, start here also the same one, same thing, right? But yes, if it is not empty, we need to traverse till here where the next is null, right? So it will happen here. Traverse to next is null, and then this time by traversing we are saying that the memory address of this one. If it is not till null, we are assigning this to this, then this till it is null. Right? After that, the next will be T, and the T is data. So now what we are doing is this null. This null will be point to this particular cell, and this will be null. Yeah, it will point out to this particular cell. So then this particular cell, this temporary node will be the very end, right? So display also can be done. What we need to do is, starting from this node, we need to traverse to each node by calling the next, right? And in each time we only need to do to print out the each element, right? So mention here this, we have defined this temporary node T is our star. So if T is next is null, that means if T is null, that means there are no any element in our linked list. So that's why it is called empty list. Right? You can go through with these ones, deleting from the front and back. So let's try out this code. So wow. So here 13. So I inserted three elements, 10, 11, and 12. Right? Let's print one. So 10, 11, 12 are there. So if our initial element is 10, right? No, our initial element is 12. So I will insert it into the front. So if we need to delete element, let's say from the end, 5 and traverse. So only 12 and 11 are there, right? So I have, I think, uploaded this code also, right? So now I am asking how to create a stack by using the linked list. කොහොමද stack එක හදන්නේ? So I will go through with the code. So this is stack implementation. So it is also have that same thing, integer data and node, right? And we are creating two variables, top one and a temporary node as well. And here we have the top. That means we can only in a stack we can only access the topmost element, right? So it is here. So if it is null, that means our stack is empty, and we need to push element. So there you need to pass the argument, and pop will return the very first element, and there is function to search the element is if the stack is empty, display. So here we can see the top element, and from here we can destroy the whole linked list, whole stack. We also have a variable, global variable count. See whether what the size of our stack. So this is empty, where if top is null, then the stack is empty. Right? This is the code to push a particular data. So how we can do? If this top is null, that means the stack is empty. We need to first initialize the node, right? Okay, the node initialization. So next will be null, and the data will be our inserted data, right? So if it is not null, then what we can do? Our stack as let's say 10 level, 10 with several elements. So then what that means is this perspective. So this node will have the reference to this particular. Consider this is a stack. So consider this is where you are inserting, right? So you need to insert something to this stack where you can insert. So this very beginning question, right? So the first question. So consider this is our node that we are going to push this stack, right? So how we can push? So there is a name, say A. So this is our stack. Right? A is the name of our stack. So A is the memory location to this initial this this particular node, which has inserted at the very end, right? Or inserted recent, right? So we need to insert this one. So what we can do is we can as we can assign this to here by using this A, right? So A is referencing this. If we assign this to this A, that means this node will reference in this, right? So then we can remove this one, and we can ask A to represent this node. Right? In this way, we can insert to the very beginning, right? So it will do it here. So temporary next will be stop, right? Next will be stop, and temporary data This data will be this data, and top this one will be this node, right? Then we can increase the count. So that means we have inserted the element. So pop. So we need to remove from the very beginning, right? So it is the same as that we did done in the link list. Then we need to reduce the count as well. So how we can do by using the temporary variable top one. Here we have initialized this top one is that means it should be error right from my empty stack. Then top one, we need to remove this one. Right. First we assigning this to a system. Right. We are assigning this to a temporary variable. Right. Top one. And then this one's next is this one. So we are assigning this one's next to, that means this node to here. So one next. Right. And we need to release this one. Right. So that means we are assigning this to here, but this memory location, what will happen? It will going to stay in the memory, right? So it is the garbage data. So by calling this free, we can remove this particular node, right? So it will happen by calling this. So first, without before that, that means we are not going to pass this variable to here, because then we cannot access this particular node, right? So first we pass this one to here, where the top have still access to this particular node, right? Then we are going to free this one. After that, the top will be null, right? Top will be null. Then we can assign this top one, our temporary variable to here, right? So by traversing through using by calling the next, we can traverse to the our elements. So top data. So top data is this one, right? So in by calling that data, we can access the very first element. Take our problem in everyone in 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 This is our step. Then we have last at the very end we insert I have inserted this line. Right. So we pop something. So I pop the value. So we can keep pop out each element. Right. You can see print out. There will only 10 left. So these values are in a linked list that is created inside our memory. Right. Yeah. You can go through with this queue implementation also. And yeah, I will ask you to create new functions like to insert something to the middle or as I mentioned, how to reverse a stack and all you can able to do by using this implementation, right? So please go through with the queue implementation. I have uploaded it to the LMS. So yeah, we can wind up the session. So if you have any questions, please ask. So students from the chat also, if you need to clarify something, please